Okay, so as you probably heard, we're here at Verivox. My name's Lars. You probably know me from the last talk that I gave at last year here at the Kubernetes Meetup. And because I've been working at Haufe-Lexware at another gig, and we had Verivox here, we thought, okay, let's bring all three of those parts together. This is why we're here. So Verivox is sponsoring the rooms. As already said, there will be pizza in an hour. Right, Martin? In an hour. And if you want to, there are drinks in the fridge over here. And yeah, we won't talk much about Verivox. Just remember that there are people with these nice little badges here that are sitting around. And if you want to know more about Verivox and what we're doing here, then just talk to us in the networking session. And having said that, Martin, take it away. Please remember to activate or deactivate the mute.
I did.
Perfectly.
Yes, but thank you for reminding me. So thank you, Marlene Blaube. Oh, no, sorry. She's sitting here. You can also say hi, also from Verivox. Thank you for organizing. Thank you for having me. So today, I'm going to talk a little bit about our cloud journey, how we lifted a major product to Kubernetes. First, perhaps, I would like to get to know you as an audience a little bit more. I guess that you all have experience with Kubernetes somehow. How many of you are running Kubernetes in production today? Okay, not bad. How many of you are using Kubernetes for like development or testing? Okay. And the rest, I guess, is using Docker, right? Everybody has Docker experience? Awesome. Okay, then it's going to be perhaps a little bit interesting for you to see what we did and how we managed to get a major product to Kubernetes. First, a couple of words on me. So I'm working as a solution architect. At heart, I'm a developer, right? So that's my background. I've been working for Haufe-Lexware, or the Haufe Group, since 2006. And I used to be a desktop developer. I was working with C#, C++, all that messy stuff for ages. And now, since 4 years, I've been moving more and more to the web world. I've been doing Docker and Kubernetes since 3 years and Docker since 4 years. And my new pet peeve is Node.js, actually. So that's what I'm doing. I'm maintaining also an open source API management solution that we are maintaining from Haufe. Yeah, so that's me. A couple of words on the Haufe Group. We're almost 2,000 people. By now, all around the globe, or mostly in Freiburg. We have like 1,200 people in Freiburg. Yeah, these are just things. You can read up on that if you want to. But yeah, we have dependencies or subsidies in Berlin, St. Gallen in Switzerland, Barcelona, Timișoara in Romania, Boston, San Francisco. And I bet I forgot some. So today, I will talk about a couple of things that were important in our cloud journey when we moved our product. So we will be talking about planning and politics. We will be talking about technology. I guess that will be perhaps what's most interesting here. We will be talking about operations, because if you move to the cloud and you do DevOps, well, you don't get around doing operations. And at the end, if we have time, I will come to a conclusion. So let's look at planning and politics. So let's set the scene a little bit so that you know what kind of product I'm talking about. Some numbers for starters. The product consists of 874,000 lines of code. It has existed for over 10 years. I think it's more like 15 years by now. There have been 10 to 15 developers at all times working on it, but some have been there all the time, some have changed. Many external people, like Lars, he was in there for a year. And it consists of over 100 active Git repos where we store stuff. And looking at the runtime, we have, at any given time during the day, 200 to 500 concurrent users. Doesn't sound that much. Typically around 100 requests per second. And our system consists of 450 gigabytes of RAM and 56 cores. This sounds a lot, and it is a lot, and there's a reason for that. So the system itself, it's a research database for law text, legislation, commentaries on law, things like that. So our typical customers are tax consultants or HR people that have to look up things. Are you using it as well? Yes. Are you satisfied? Did you notice that we moved to the cloud? Good. Okay, so HR people know us. So we have a big market share in these things in Germany. So, and the reason why we need so much memory and stuff is that we have a full-blown search engine inside here. So it's actually search engine that we wrote ourselves like 25 years ago, and it's very, very memory hungry. So that was one of the main things that we looked at when we figured we'd move to the cloud. How will we manage this? Do we find hardware that is actually potent enough? But that wasn't the issue. Now, looking at that thing, it's a legacy web app, so it's Java-based. It was Glassfish 3 back in the days. And that thing is really a major revenue source for Haufe. I actually had numbers here, but I wasn't allowed to keep them. So but it's a lot of money that is going through this product. And we had it hosted with a hoster, and that hosting was really expensive. But that wasn't actually the issue because the revenue was so good. So the hosting costs, well, okay, fuck that. But where we had real pains was that we had really long release cycles. And we had a lot of manual work to actually get releases done. The hoster said, we want to know 10 days in advance, 10 working days in advance that you want to do a release, and then we have a lot of acceptance tests and whatever, and these things. So, oh, I'm seeing people nodding and doing, yeah. And we had to do that because we didn't have more than like 3, 4, 5 releases a year, mostly because that was so work intense. Yeah, so we had lots of manual work for those releases. And another thing that hurt us was that we had a non-parity between development systems and production systems. The production system didn't actually have anything to do with what we worked with on a daily basis in the dev systems. So whatever we changed, we first had to do that on a staging system, and then we had to try it out, and find out that things simply didn't behave as on the development system in production. That was really painful at times. That meant that we had to fly blind when we did changes. We had little operations insight, and any errors that we saw that the customers were experiencing, we didn't see what the reasons for those things were, because that was kept with the hoster, and sometimes they managed to update the logs and give us the logs, but we didn't have real-time access to the application data. On the good hand, or on the good side, we have and had a very modular architecture. So it was clear that we can take out parts of that thing. It was fairly well written, and from a development side, it was okay. It was a monolith, but it was not bad. And another thing that played in our hands was that as a company, we had decided to do a strategic move towards containers. So this was also one of the main things that made us look at Kubernetes, look at Docker. And now we said, hey, let's convince our hoster that we want to run Kubernetes with them. That would be the best thing, right? What was the decision made? Around what time? 2 years ago, yes. So early 2017 was when we said, now we will do this. Now, the point was our hoster didn't have any kind of container experience. We tried it. We tried really hard to convince them to have us use and manage Kubernetes from them, but it just didn't work out. No chance. So the solution, okay. So we sat down and we thought about how do we actually want to work in the future? What do we want to do? So how do we want to make things more efficient? How can we increase or reduce the release time and all that kind of stuff? We sat down, we had 4 goals. We wanted to do CI/CD. Okay. Going from release cycles of 3 months to CI/CD, that sounds like a bold move, but that was our vision. That's what we wanted to do. And we wanted to have automatic provisioning of environments so that we could be sure that we had everything as code that made out our environment. Try that with a hoster. We wanted to have full operational insight. We wanted to be able to see what was actually going on. And at the same time, we didn't want to do a lot of ops ourselves. So it was easy. Let's go DevOps in the cloud. And that concludes my talk for today. Thank you. No, sorry. Then we looked at that even more. We were like asking our stakeholders, is this a possibility? Do you see that we might be able to do this? And there was a lot of politics, a lot of talking, a lot of convincing them, and seeing how they reacted. And when we got first positive reactions, we sat down and just brainstormed. If we go to the cloud, what we have to do? So this is just a Trello board of really rough things that we found out in 2 hours. And we were like, oh, wow, this is going to be a lot of work. But we said, okay, we commit to doing this in 6 to 9 months, 3 to 4 people. That's how many worked on this. And we got the go from business. And then we got started. So now, while brainstorming, we found out that we have like a lot of different types of things that we have to take into account. So it's one thing is technology, right? Technology was quite clear what we had to do or what we wanted to do. But there were more things like project interfaces. Where do we have interfaces to other projects in the company? We are just the platform that displays content, so we have to get content in, content out, and all these things are intertwined in some way. So that was also one of the big things to really find out the interface between the different projects. Like processes, where do we have processes that touch things? It's similar to the project interfaces, so we had to look at that and also talk to these people. Hey, we are changing stuff. What do you think that will mean for you? Those were processes that were implemented like 10 years ago. Nobody had touched them since, and we wanted to move everything to the cloud. And then we had soft topics like HR topics, operations. We don't have a hoster that does operations for us anymore. What does that actually mean in terms of HR? So it's a lot of stakeholder management that you had to do. So this is something that I really want to stress. If you have like a larger company and you want to do this kind of project, you have to do stakeholder management all over again. You have to really, really work with them. You have to convince them. You shouldn't persuade them, but you should convince them that it's the right thing to do. That also makes you think about what it actually means for the project and what the business value of that, what you're doing is. You have to communicate often and really clearly what you want to do and what kind of impact that has. And you shouldn't underestimate this task that you should do. It's a lot of work, and you should really be super clear about how much work it is and what kind of impact it has. So be transparent, share successes, but also failures. So when you have the feeling that you went wrong, speak to your stakeholders, make sure that they are totally clear where you are in the process of this thing. So the reason why I put in these slides is I want to show it's a lot of politics, a lot of planning, a lot of talking, a lot of just making sure that everybody's on the same table or on the same page. The same table, sorry. Everything is on the table and on the same page. So another thing that we looked at when we were planning these things was how does our team have to change? We had a really classical team. We had developers, we have test engineers, we had release managers, we had whatever, yeah, you name it, product managers, and that was something that we said, no, actually, we would like to have a team that consists of 100% DevOps engineers. Everybody should be able to do everything to a certain extent, at least. So, like T-shaped engineers. Who has heard that term before? Everybody, right? No? So a T-shaped engineer is somebody that knows a lot about many things, or little about many things, and has like peaks in their knowledge. And I think they said T-shapes to not make it this, like, but it's the same thing. Or they also say W-shaped, like you have peaks in your knowledge or in your skills. So that you could, in principle, do whatever, but there are things that you can do better. But everybody has to know ops. Everybody has to know at least the basics of development, right? So we didn't want to have dedicated manual testers anymore because that simply doesn't fit. You need to automate the tests, and test automation is something completely different from manual testing. So we need a different skill set for that. Even if it's still testing, it's different because we need it automated. Like, yeah, automated, you build it, you run it. Ops experience? Okay, we didn't have that. But we said, we'll learn it. It's fine. We take on that. We do that ourselves. We can do that. We will read up. We will learn while doing it. So, as I said, HR topics, we actually had some, and those, you can't neglect them. You have to look at them and really talk about them. Things like, yeah, operations responsibility, we have to take that on. And that means things like, okay, wrong order, story messed up. Let's just do this. So what about on-call duty? Does that work with our contracts? We have to find out. Or what will the service level agreements be towards our customers? Can we do what the hoster did? Or do we have to like find other solutions? So it's more politics, more planning, more looking at these things. Nonetheless, very, very important to get the feedback from your stakeholders and also from the team. Are you really willing to do this? Because without the team dedication, you can forget this. It doesn't work without team dedication. You can't impose that upon a team. The team has to be willing to take it on. Otherwise, it won't work. Yeah. Other things like quality engineers, manual testers, they had to be to be willing to also pick up new skills like automated testing, Selenium tests, or whatever, things like that. That was okay, but it was a rough start for these people who had, up till now, perhaps just done a little bit of scripting, but not hardcore Java, Selenium, whatever testing. That was difficult. Same as the release manager. We actually wanted to abolish the release manager. We didn't want to have those. We wanted to do CI/CD. So a lot of nervousness, a lot of insecurities that you have to address to not make this thing blow up already in the planning phase. Okay, so yes.
Still had a product which was earning money.
Yes.
How did you do this in parallel?
We did this in parallel with, as I said, 3 to 4 people out of 10 to 15 did this mostly. So they were like taken out of daily business and could concentrate on that. So I think that went well because if you have to do it in parallel and really do daily business and maintenance of that product, it's difficult. So you really have to focus, and that was like a, I don't know how you can call it, like a, yes, correct. Plus, that's not covered here. We did a pilot with a small part of the product first, so that we actually moved one part of the product to the cloud first, and then we took over the rest. Yeah, so technology, what did we choose? Yeah, just feel free to ask questions anytime, right? So it's always good. The technology stack that we were using was like Kubernetes. What a surprise. It's the Kubernetes Meetup, so it's Kubernetes. And we did it on the Azure public cloud. This is not significant whatsoever, whether it's Azure or AWS or DigitalOcean or whatever. In the details, it is significant, of course, but the big players have the same feature set. It's okay, it's fine. So this is what we used. Now, as I said, we wanted to do CI/CD. So we sat down and we were thinking about these things, and also how we could actually ensure that we could do ops ourselves. We knew that we didn't have experience in running VMs or computers for a long time, like long-running systems, super site reliability engineering, whatever. We knew that we didn't have these skills. So we chose a somewhat different approach to other people are doing. Yeah, Lars is smiling. We had our fights. But I still think for this product, it was a good thing to do. So what we do is we provision things. Provisioning is like creating VMs, setting up a cluster, things like that. We deploy our product. And when we have done that, we go into a second phase where we actually just do CI/CD. Now the kicker is, we do this provisioning and deployment stuff once a week for production and daily for the development system. So what we actually do is we throw away the entire development cluster every night and we create it every morning. Okay? And for production, we actually do CI/CD. So when we have finished something, we deploy it to the running production cluster, just like it is. So this was how we wanted to do it. Now, it sounds strange. You throw away the production environment once a week. That sounds weird. Like, usually you don't do that. But we have reasons. So what we wanted to achieve was 100% reproducible deployments. We wanted to make sure that we have everything in code. And by doing that, or by throwing away the environments every day, we make sure that we can reproduce them daily. So remember, target no ops. We want to keep our hands off that thing. And yep. Excuse me? Yes. But I will talk about persistence later on. Okay, that's a separate topic because that's exactly the difficult part. Yeah. So the thing that happens here is also that we can practice disaster recovery daily. So what we do is we actually reproduce the entire development cluster, including the data that we get from production, so that we have production data in the development cluster every day. So, and that would also be the same thing that we do with a production, or if something goes really, really bad, we would just throw on that pipeline again, and then we have a new production cluster. Excuse me? No, we don't have to, because the nature of that data is largely semi-static. So we don't store that much data from the customer. It's just bookmarks and things. And those bookmarks are just IDs. The identities come from somewhere else. We just get IDs back. So we don't have personal data. We don't have anything that is of worth for anybody. So the data that is important here in this is the intellectual property of Haufe. It's a research database. So it's a special case, and it's a very, very valid question for most other products, but here it doesn't matter. Yeah, as I said, on-demand production identical environments. That was a really nice thing. We can spin up a second production environment and test things on that thing. So we have no long-running systems. We have no systems that run for more than 7 days usually. Or if that fails, it will be 8 or 9 days until we manage to spin up a new production cluster. But usually it's just 7 days. And we can do incremental changes, both in terms of CI/CD and also in terms of infrastructure. And that is a really important thing that I have seen people kind of ignore. When you build up such a system of open source software, you have a lot of third-party dependencies built into your project. And if you update those, you need to validate that your system is actually still running. I've added here like the most blatant or most common dependencies that we have in there. So I don't even know what that is. This is Spring, this is Azure Container Services, Mongo, Postgres, Kubernetes, Prometheus, Redis, Fluentd, Graylog, Grafana, Nginx, Wicked. What's this? I have no idea. Ah, yeah, it's Elasticsearch, right. Payara and Kong. So these are there are like tons more. And you still have to make sure that these can interoperate, and you want to try that out before you actually apply it on production. So this was for us a really, really powerful thing to be able to say, okay, let's try Kubernetes 130. Let's spin up a dev cluster. That works. Is it stable? Yes, it's stable. Okay, we will apply it next week on production. Like that. So it's all in the end, code and pipelines, right? It's code and pipelines. And pipelines are also code, so it's actually just code. So if it ain't in Git, it doesn't fit. So everything goes into the source control. Now, everything is in source control. From the ground up, the scripts, how we provision virtual machines, the scripts, how we provision the clusters. We have no manual intervention whatsoever when we spin up a new environment. It's all automated. Takes around 90 minutes right now to do that from scratch. Yeah, so this enables us to have these CI/CD kind of workflows. So a typical thing when we do a backend update is that we merge a feature to master, like after a code review. And that obviously has to include changes to test suites. We build the master branch. That includes unit testing and first integration tests running. Then we deploy to the integration system, where it actually tries to integrate into the running system in that integration stage. So we have 3 different clusters. We have a development cluster, integration cluster, and a production cluster. On that integration cluster, we run tests that actually involve all the depending services so that we know that it still behaves in a way that makes sense or that makes sure that the cluster is still running. And then we do the same with the production cluster. So that typically takes half an hour all in all to get a new feature into production without manual intervention. Yeah, front-end development is more or less the same, except that you do end-to-end integration tests instead of running the integration tests in the backend. So that we actually deploy stuff to the integration system, we run the end-to-end tests using Selenium or whatever, or a Chrome driver against them, make sure that everything still works, and then we deploy to production. So for the front end, that is actually fully automated, and that takes less than half an hour. I think that takes like 12 or 13 minutes from the merge until it's live on production. That can be faster, but it's fine for us. It's enough. It's fast enough. No, yeah. Excuse me? Some components have started doing that, but it's largely up to the different components how they want to, or the maintainers of those components, how they want to test their components. So we have a large variety of technology and also different things. So I can't tell exactly now. It's not my area of expertise. Sorry. Yeah. As you have seen, like this is awesome for stateless components. And as you pointed out, what you do now with the stateful components, this is more interesting. We did find a solution for that. I'll just show you briefly how that works for us. Now, so if we do a full provisioning, we usually start by creating backups. I don't know how many data stores we have right now, which have to be backed up, but it's like 10 to 12 different ones, different Postgres, different Mongos. So each microservice that we have inside there, they have their own data store, and those have to be backed up. Then we provision a new infrastructure from the backups that we just created. This means we actually have a downtime once a week of around 90 minutes. This is okay for us. This may not be okay for anybody else. But this was something that we decided it's okay, it's fine. It's actually not a downtime. It's actually just a period of time where you as a customer cannot store data into the cluster. The application is still up. It's still working. Everything is fine, but you can't store new bookmarks and things like that. But that was one of the drawbacks with this thing. But we decided it's okay for us. But there will be other solutions. So, and then we deploy the components using the regular pipelines that we have for CI/CD. So we just use what we have, deploy these things, and when that is done, we have a big DNS switch where we actually just switch over to the new cluster, and then we destroy the old infrastructure after that, after the tests have finished. So this is how it works for us. Now, this thing from backups, this is freaking hard. And if you can avoid this, don't do it. Now, persistence options.
So
Yeah.
you're deploying your own Postgres in containers as well.
I will get to that. Right now, we don't.
Because I would have said if you use native services on Azure or from the cloud provider, you could have actually.
Okay. Yeah. You're right. So what we did here is we rolled our own persistence right now. So we have self-managed VMs, and we even have an NFS inside that thing. Or you can go with persistence as a service, like managed disks or database as a service or files as a service. So this is how it looks like for this application right now. So we have the cluster, and we have a NFS VMs, and we have Postgres VMs. This was like 2 years ago. So this is largely due to that. So the thing is, the NFS we needed because on Azure, the Azure Files driver was simply not fast enough to keep up with the speed that we needed to read our data. We're talking about these products, which are like these research databases, and that's around 500 gigabyte of data that we more or less need to keep constantly in memory or read from disk constantly. So the thing was, we needed read-only access to that data from a file share somehow, but we needed it from many instances. And that didn't work with Azure Disks. There you just can mount it to one VM, that's it. And the Azure files, they were simply too slow. Same thing with S3. S3 is also nice. It's a really flexible file store, but it's not fast enough for what we needed. Yeah.
cloud service?
No, it's an SMB service. So it's Samba. That also meant that the legacy components that we had inside there that relied on Unix type shares with the rights management and all that kind of stuff, it didn't work. It didn't work. So we ended up with an NFS solution. Excuse me? NFS. That was bare metal services, NFS, yes. Yeah. They had some NetApp solution, whatever. And there we got NFS shares. So to make that easier, we chose to do it this way manually with the VMs that we provision via Ansible scripts in this case. The same with the Postgres. Back then, the Postgres as a service on Azure wasn't finished. It didn't work well and it was slow. So we actually created a Postgres VM that we were able to tweak like we wanted. By now, I can say that the team has come to the conclusion that they will take away that thing and they will run Postgres inside the cluster instead. I'm not sure whether it's a really good idea for everybody. For that team, it works because they have really grokked how backups and restores inside the clusters work. But that is a skill that you have to build up. Yes. Because it's fast enough. Speed is not an issue inside the clusters. They are blazing fast inside the cluster. Same, we also run Mongo inside the cluster, which is totally fine. It's a lot faster than anything that you get as a service. And the nodes are managed by Azure, and it's it's also dead. It handles it fine enough for our use cases. You have to assess that. I have a slide on that later on as well, where you have to think, do I need a cluster of Postgres inside the cluster? That would also work. But usually it's, for our use cases, it's okay if, for example, one Postgres thing goes down inside the cluster, it gets recreated somewhere else. And we have, for one microservice that is using that Postgres, we have a downtime. But that's a question of how you handle outages from your application of services inside your cluster. Yes, correct. Yeah, and as you can see, you have like endless variants of how you can solve this. And I just wanted to place some hints here. And that would be, early on, check what your persistence needs are. That would be one thing that you have to look at. Where do we persist stuff? And how does that work today? If possible, use databases as a service. Get around this entire hassle thing. Make somebody else run your databases for you. Because if you can keep the state out of your cluster, things get so much easier. The current project where I'm using, we do that. So we have a managed Mongo database, and we have a managed Postgres database, and inside the cluster we have nothing in terms of state. So it's a lot easier because it's somebody else's problem to run those databases. Configuration of these things, externalize those. Make sure that you can point your databases or your persistence options to different things. Easy inside Kubernetes. Use headless services or whatever. Make sure that you can switch that out quite easily. Don't hard code it. And what we also found out, and that was why we ended up with NFS, shared file storage is not cloud native, and nobody likes it. Okay, and it's not well supported. So if you end up in a situation where you need shared file storage, think again, perhaps, because it's stupid. Okay, it's not a good idea. it's what we have right now. Okay, how's time? That's still good. Okay. Yeah, and just ask questions if I'm too fast or whatever. Yeah. No, we are using it's a mixture right now. So most things we're using the Azure command line for, like provisioning the cluster, and we are using a tool called AKS Engine that makes it quite easy to spin up Kubernetes clusters. And Ansible we only use for those VMs where we install NFS and we install Postgres. So we're trying to phase out that and run more and more inside the cluster or use services for it. So it works. It's okay. There are good recipes or runbooks for most of these things. But for Kubernetes, we're using what the cloud provider gives us, so that we also have support in these things. And that's really valuable. Okay. So we're at another big topic of this talk, and that's operations. And no, you don't get around it. And I'm very sorry. I mean, us developers, we're just happy. Yeah, we got a cluster. Yeah, it's running, and yeah, it's fine, and we can totally do this. And then you start to experience problems. You have issues, and things don't work, and you have no clue why. So operations is actually a really big part of what you have to make sure you get it right. Otherwise, it'll be a mess to actually do DevOps. So now that we have Kubernetes, what are we going to do with it? Now, you say it's production ready. It is. It is self-healing. It is sometimes, mostly. It is robust. Yeah. It is battle-proven. Yeah. Yeah, I mean, it's getting more and more battle-proven, right? But as you see here, not that many people are actually running it in production yet. Big players, yes, but small players, well, not so much. It's complex. It's an additional abstraction layer on top of everything. So it's not that you just have to manage your VMs. You now also have to manage Kubernetes itself, and you have to make sure that everything works. Now, so, as you say, Vertrauen is good. It's good to have faith, but it's even better to have control over what you have. Right. Now, control, what do you mean? A start would be to detect these things. Right? Okay, containers on fire, and you don't even notice. That can happen. It happened to us, so Lion monitors. We had a situation where the end-to-end monitoring was saying, it's all good, all green, everything's fine. And the people logging in got 500s, and only 500s. Redis had broken. We didn't have a clue, and we had that for an entire weekend. It was outside of our SLA, so it was kind of fine, but it was still like, yeah, this shouldn't happen. At least we should notice. Even if we choose to ignore it, we must have noticed it. We didn't notice. We noticed it when people called us like 7:30 Monday morning. What the fuck is going on? It's not working. What is wrong? We went, oh, it's all green. Yeah. Log in. Oh. So yeah, that was bad. That was like a month in after we had switched to the cloud. So operations is something we are still learning as well. And every time something goes hayward, we learn even more. And it's always new stuff that goes wrong, but that's normal, right? So how do you prevent these things? So it's actually fairly simple from the methodology. What you have to do is that you have to instrument your things. That is, you have to extract data from all of your components. And then based on this data, you can do monitoring and alerting based on these things. And what you also want to do is that you want to enable insight into whatever you are doing inside your cluster. So that's something that you want to be able to observe your running system. So how does that work? What we chose, what a coincidence. It's a CNCF product. It's Prometheus. So this is the Prometheus logo. Who has worked with Prometheus here? Okay, so this is going to be news for many people then in that case. So we chose to deploy Prometheus inside the cluster. Prometheus is really good at getting data from various components. So what it does usually is when you have a component, let's say component A, Prometheus assumes that there is an endpoint here. That endpoint is called the metrics endpoint. It exposes data from that container so that Prometheus can actually get that. It assumes that it has an HTTP endpoint called whatever, metrics. And that thing, it calls regularly, like every 15 seconds. And it does that for every container or every component inside here, plus other things that you can add. Then it stores that into a time series database, which also has to be persisted, of course. And then you can do stuff with that. So there are a lot of things that you get out of the box with some libraries. You can get like JVM metrics, node metrics. There are metrics exporters for VMs that you can install and run also inside the Kubernetes clusters. Database exporters that export statistics on the database. So this is really a standard technology. You can find stuff for everything. So Prometheus is really well supported in that case. And what you can also do is that you can instrument your own code using the Prometheus client libraries. So you can put in code into your own components and read out stuff that has to do only with your application. And now that we have these metrics, we can do the following thing. We can use Grafana to create dashboards on these things to really look into what is happening inside the clusters in real time, which is really cool. And what is even cooler is that we have that thing called the alert manager that also queries or that is called by Prometheus based on certain rules that you can define. These can be really complicated rules. Like, for example, the response times have been higher than 500 milliseconds on average for the last 10 minutes. Things like that you can do with Prometheus if you have the raw data in. And that thing you can use to forward alerts to, for example, chat system or email or PagerDuty or whatever. So there are also plugins for that. We are using Rocket Chat and email in our case, which is usually enough, as we don't have a need to get up at night to fix things usually. Yeah, so this is a really powerful Lego type of system that you can use, and once you get that infrastructure up and running, you can do whatever with it. That's really nice. Now, metrics. What kind of metrics do you have? So you have like two different big categories of metrics. You have white box and black box metrics. And with white box metrics is what I can gather from inside a component. So what my latencies are that I think are, or how fast can I query my database, how fast can I deliver pages, things like that, or what are my response codes that I have, what types of, or how are the response times spread over a certain histogram, things like that. And black box, on the other hand, is something that you measure from the outside. So what we also do here with this product is that we have measurements inside the cluster that looks at how does it perform from a white box perspective. But we also have tests that are driven from the outside. Selenium tests that run somewhere else, so that we can actually make sure that we can run tests, like it runs once a minute and checks, can I reach the usual endpoints from the outside and how fast is that? And the metrics that we get from those are the so-called black box metrics. That's how the customer would perceive the product from the outside. So doing both these things is a very, very good idea. You get more data from the white box tests, of course, because there you get the entire traffic of the entire cluster. And from the black box tests, you just get the data from what you are driving yourself. So it's good to have both things. Yeah, and there are different types of metrics, like counters that count events. You have gauges that counts things that go up and down, like CPU usage or disk space or whatever. Histograms, really interesting, where you can say, I have these buckets of response times, for example, less than 10 milliseconds, less than 50 milliseconds, less than 100 milliseconds. Then you can see on in these different buckets how the services actually behave. And that also unlocks things that I will talk about later when calculating service level indicators. Yeah, and what kind of metrics, types of metrics? You have infrastructure metrics like disk space, CPU, memory, pod status, network latencies, errors, timeouts, and then the things that come from your own business logic, whatever you decide to create metrics on. So, and that leads to an effect that you start to observe things. And in the beginning, you're not quite sure that you like it because you see a lot of things that you might not expect. For example, here you see, oh, we have spikes in these endpoints. Oh, this looks bad. Oh, we didn't expect this response time to be that bad. And you see these kind of things, and you start to find even more work that you should do. But it's fine. You can still see this thing, and you want to see these things, and you want to be able to observe these things. No. Yep, no idea. We had like gut feelings. We had performance tests that ran on a specific environment that was also bought by the hoster, and then we ran Selenium type tests on that and measured the response times, but it was bullshit, to be honest. This is so much better because this is really driven by actual customer traffic on the actual environment. And you also see things like, here, Friday 9 o'clock newsletter, boom, and we get a peak in logins. This is nice to see. So it's just a typical thing what you will be able to see after that. Yep. Yes.
So currently also in the phase where we have concepts that are driven the outside. Production of cloud tests.
Yes.
Can you bring those together?
Well, to be able to assess whether your intended infrastructure behaves the way you think it should, you need some kind of driver. So you need to put load on it. And in the first iteration, you have no other means than creating the load yourself. Lars can tell stories about that because that was what he did. He created a whole framework for really putting our system under pressure. So in that phase, you need to do it from the outside. You can still measure that with these tools from the inside then, but the load will still be artificial, but you can control it.
So what we have is the load how to measure.
Yep.
Then to still having the load from the outside.
Yep.
And but then we use the same live systems as in production.
Correct. Yep. That makes it possible to observe how the system actually behaves under load. So you can look at it. It's not just works, does not work. You can see exactly which component is the bottleneck.
Same thing that later production.
Exactly. So in the end, we observe things, and of course we like it, right? Okay, of course we like it. So this number, 205,886, that's the number of time series that we collect every 15 seconds inside our systems. Prometheus can take a lot more, but this is what we have right now, which is a lot. So we have metrics. What do we alert on? You have the choice. So you have to pick some. So a rule of thumb is you should probably alert when your infrastructure goes down. Like pods aren't available, nodes start to die, things like that. Rule of thumb, if you have to act on it, alert. If you don't have to act on it, don't alert. Even if a node goes down, who cares? It will come up eventually. It's self-healing, right? And mostly that actually is true. But we have also found out that it's super hard to find out which alerts we need and which alerts we don't need. So in the beginning we had too many alerts, and then at times we had too few alerts. But usually when you find something, you alert on it, but actually you shouldn't alert on it. You should rather fix the root cause for it. Then you don't have to alert on it anymore because it doesn't happen. And if you alert on everything that has happened once, that's what they call airport security, right? So it wasn't me coining that term. I have forgotten who it was, but it happened once, so we need alerts and fix it. Then it won't occur again. And what you also should alert on is availability. Does the website actually respond? Does it do like a basic test? Can I log in? Can I perform the most basic use cases? And that would usually and typically be your availability. Now, is that enough? Probably not, because even if it's up, your users might not be happy because it's too slow or it doesn't behave right. So Mipsy Tipsy Charity Majors from Honeycomb, you should follow her on Twitter, totally. She says, 9 don'ts matters when users aren't happy. Now, when are users happy? We want to find out when users are happy. And this is actually really difficult. And it's something that is really tied to your business logic and tied to your business values to find out how do I find out whether a user is happy or not. You can make educated guesses. And for us, these educated guesses looks like this. We have defined so-called service level indicators. For us, it's like the percentage of document retrieval requests served within 0.25 and 1 second. So these buckets come in again, okay? These are retrieval times. And percentage of search requests answered within 1, 3, and 7.5 seconds. And percentage of error pages. And then we have agreements that say 95% of document retrievals have to be served within 250 milliseconds, and 98.5% have to be served within 1 second. And similar for pizza, similar for the search requests. So this now closes the loop to the metrics that we actually calculate with Prometheus, because these service level indicators we can just take out of the raw data that we have from Prometheus. Plus, we can calculate them for a given timestamp, for example, or timestamp, for example, for today, for the last week, or whatever, so that we actually have these numbers pre-calculated. We can always show these are the service level indicators that we had at that given point of time. And we think this is what makes our users really unhappy if we don't meet them, at least that. We can't tell whether they are happy, but we can tell that they will be unhappy if we don't meet these things. Yeah, so this is a typical dashboard that we can see. So we have these shown. People say you shouldn't show dashboards, but dashboards are kind of nice anyway. We say here, these service level indicator searches, documents, error pages ratios, and these are the end-to-end tests. Like search for a predefined term end-to-end should not take more than 2 seconds, and these things. So we always have these service level indicators. Whenever we want to see them, we can look at them. So this is the first thing that we look at. If we get a call or something looks weird, we look here.
So if you have these metrics and you see, for example, the search is going down, not reaching your SLA, I mean, what options do you have? I saw a little bit that you are not that scalable due to some items like the NFS.
Correct.
Kubernetes allows you to spin up a couple of more stateless.
Yes, we're not doing that. We have right now a set where we know that we will satisfy these things usually. So
the maximum provisioning.
Yes, we have maximum provisioning usually. Yes. So we have plans that we might, for example, at night take down half of the nodes because we don't need them at night. But we don't do that yet. These things turn out to be really complicated when you actually try to do them. So right now it's like a full provisioning or maximum provisioning so that we can know that even during peak times, we can fulfill the SLAs usually. Yeah. Nope. That's also one of the things with this product. We have a really calculatable amount of traffic coming in. We have paying customers, and the paying customers are using it. And it's usually really, really easy to predict the traffic. If you don't have like multiple newsletters sent out, and people start hammering that thing. But usually that doesn't happen. So we have a holistic view now. So we instrument early and quite a lot. And as we know how these things work now, even if we introduce new components, these deployments of new components, it's easier. We know how it works. We follow with the same patterns every time. It's fine. So we also have a lot less fear of changing things because we can track them, we can observe them, we can see how they behave, first in the development system, then also in production. So we see these things, so we don't fear actually updating components or making changes or doing things. It's a lot easier to have faith in your system if you work like this. So we are in control, or at least we hope and think we are in control most of the time. And that's true. So it works. We have been live now completely in the cloud for a year by now. We rolled out the cloud migration in February 2018, and it has been running since, and we haven't had downtime since. Not really substantial, except for that weekend. So I have a couple of fails that we saw. First fail, networks are unreliable. Connections will fail, so deal with it. Use circuit breakers and retrying mechanisms. That's what you asked for before. This is something that you have to build into your application. You have to make sure that it can deal with broken connections or that services are down. This is something that you can add over time. Yeah, and learn how to detect these problems. Create metrics on these things inside your services that depend on other things so that you can see those things. And VMs are sometimes patched or restarted, or they just die. So will any service on them? So you have to deal with that. And if you have a single point of failure, that single point of failure will eventually fail. Assess it and act on it. Or say, the rest of the system is resilient enough that we can take that. It's okay. But you have to be aware that that can happen. And one other thing that was really stupid, re-establishing TLS on each call to external services is expensive. And the guy that has the service will hit you, so use keep alive. Yeah. That was also one nice little thing where we clogged up the the load balancer of an external service provider, because every time we created a new TLS thing and it used sticky sessions, so after like, I think it was 16,000 calls, that thing didn't answer anymore. That was interesting. So, okay, wrapping up. Conclusion. Was it worth it? Would we do it again? Oh yes, we would. The reason for that is in the next slide. Some key performance indicators. So by moving away from the hoster, we have a 70% cost saving on infrastructure. This was actually not that expected, but that's how it turned out. So we're paying around 30% of what we paid with the hoster. The release effort is down over 98%, from like 6 to 10 days, including, it's a little bit hard to tell, but around 10 person days of manual work. And now we're down to half an hour of non-manual work. So it just takes half an hour to release things. High release pace. We had 3 to 5 releases per year, and now we are at 15 to 20 per month. So we really roll out changes really fast. When something is done, we roll it out. So that also releases or reduces the risk of releasing stuff to a minimum, because if something really goes bad, you know exactly what it was. It was your latest release, so you roll back to what you had before. We can measure the performance, and as we have everything in our control, we can react faster to issues in the running system. Yeah, and another thing that is really nice is by running in the cloud, we can also unlock cloud technology. We can use the services that we have in these cloud platforms, which was not possible before. So we can really leverage whatever services that there are there. We're not doing that much here, but it's still something that will come in the future. We will go with databases as a service. We will go with managed services for this and that, and machine learning and whatever is in our pipeline for the next couple of years. And this migration to the cloud unlocks these things that you only get in the cloud. Yeah. So, conclusion. So, Kubernetes operations, it is possible as a team. It is. But you need team dedication. Everybody has to be in on it. Everybody has to take on having to do operations. So rethinking ops is really challenging. You have to do a lot of planning, politics, everything like that. And it requires full automation. Otherwise, you won't be able to reap all the benefits of CI/CD. You need full automation also for test. Test, perhaps not full automation, but you need to have the most important bits and pieces covered with tests and automated tests that you can run against the running system. There is no silver bullet. I am so sorry. There is no silver bullet. So you still have to assess your requirements for doing such a thing. But it's possible. It works. It was a lot of fun. It was a lot of work. But in the end, it was totally worth it. And also 1 year later, I asked the team, do you think it was worth it? Would you do it again? And they said, yeah, absolutely, absolutely. Just for the ability to release changes on a daily basis, they would do it again. Notwithstanding every cost saving or whatever, the team doesn't care about the cost, right? They just have to care about it when business says it's too expensive. Otherwise, they don't care. But they would do it alone for the CI/CD parts. They would do it. Yeah, and I think that was my last slide. So yes.
So the Kubernetes piece was quite little, actually. You could have run all of the CI/CD pipeline with Terraform or with other type of infrastructure, the code scripting, your maximize your workset.
I wouldn't say so. We are using a lot of Kubernetes goodies inside. For example, that wasn't really part of the presentation now. It was too much anyway, and the pizza is getting cold. So Yeah. So, but we can talk about that later. We're using like services and green blue deployments inside the Kubernetes thing, and these things will get, it's super complicated if you have to do it with Terraform or with scripting or whatever. Don't go there. You have this awesome set of basics and awesome set of building blocks for wiring services and doing load balancing and all that kind of stuff that you get inside Kubernetes. Use that. It's fine. So we wouldn't have been able to do it without Kubernetes. I don't think so.
I have a question. Maybe you said it, but I didn't hear. Is there a reason you chose Azure?
Yes, there is a reason. And the reason was that we weren't sure whether we will be forced to use Azure Germany for compliancy reasons. So we started with Azure. We found out it's good enough. It's fine. It's okay. We stick with it. But it could just as well have been AWS. I would estimate the effort to move to AWS would be a month, something like that. Most of the technology is vanilla Kubernetes or Ansible script, so you would have to change the provisioning, and you would have to change a little bit of load balancers and stuff like that. But in the end, it's more or less provider agnostic, what we did.
All right. Then I would like to thank Martin very, very, very much for this really great talk. And just on a very, very little part from my side on the KPIs, the most important part was not on that slide. It is what Martin said. Because when working for 18 months with Haufe-Lexware and with the specific team, the greatest thing that I took and the most vivid experience that I still have in mind is the feeling in the team. So when they started with the monolith and they were coming from all of these very little releases, like it was always a painful experience, always a lot of QA and so on and so forth. And it was so great to see the first time that Martin pushed the button on the Jenkins pipeline and everything was live on Kubernetes. That was a great feeling, and all the team was really roaring and rooting, and it was just so great. Then obviously everyone was still like, it was Martin doing it, right? So he's the specialist, he's the architect. And then one of the developers had to push the button. And that was like, yeah, now the developers can do it. That's great, that's awesome. And then it was like, okay, you know what, now everyone can push a button and we get the new release. So let's plan that for tonight, 3 o'clock. No one's watching, no one's doing anything. You know what some of the developers did? Put in an alert at 2:55 because they were afraid. Yes, I know of one developer. One developer that actually got up in the night to have a look at the system just because they were so afraid of it. And now to hear that after this cloud journey, now no one cares about deployment because it's normal daily work. It's just like, okay, I push to this branch, looks great, let's click on deploy, and then I start develop again. And maybe I'll have a look at it. But if not, okay, I'll be alerted with that. The feeling of empowerment for a developer just to know that this part of this daily business is just away from me. It just works. And if it doesn't work, I'm sure that the old version will still be here. No one will call me for that. That was so essential for me that it was really completely great to feel that and to be part of the team during that specific phase. It was really great. Okay, thank you again for sharing this with us. Could you put one slide up, you know, the sluggy, the jockey part? Thank you. So because usually we have 2 talks, right? But we thought, okay, you know what? There's so much great energy that we will get from here. So this will be the last slide, and then we will go into networking, and you will get your well-deserved pizza. So we have a lot of topics that are interesting, and we are always obviously searching for speakers. So we got Martin now. I also did a talk. So if you have any topic that you think is interesting, or maybe you feel that it might be interesting, it doesn't really matter. If you want to take part and do something, then please join us in the Slack channel. In the general, just get in there, talk to the three guys. Could you stand up for a second? I mean, you already know these three guys, but just in case you don't know these three guys, these are the guys to talk to get some topics in. And if you want to sponsor something, feel free to do so. Obviously, if you have a topic about that, great as well. And yeah, I think that concludes our part. Pizza time.